In 1610, Galileo saw Saturn, but he didn't understand it. His telescope showed strange ears, not knowing they were icy rings that would puzzle humanity for centuries. Today we know those rings are vast, delicate, and possibly vanishing before our eyes, a cosmic masterpiece, fading in silence. Scientists think a lost moon or a celestial collision may have created them. But we still ask, why Saturn? Why not the others? If you stood beneath those radiant bands, would you feel awe or sorrow for what's slipping away? Let's explore the truth behind Saturn's vanishing crown. The enigmatic beauty of Saturn's rings. If you were standing on the surface of one of Saturn's moons, you'd see something that almost doesn't look real. Towering arcs of shimmering ice stretching across the sky like a celestial ribbon. For centuries, this sight has mystified stargazers and astronomers alike. Saturn's rings aren't just decoration, they're clues. Clues to a violent cosmic past, to the invisible forces that shape our universe, and to the kind of beauty that only space can sculpt. But what's wild is that when Galileo Galilei first saw them in 1610, he had no idea what he was looking at. His telescope was primitive, and to him, Saturn looked like it had ears. It wasn't until decades later that scientists realized these weren't ears or wings, but rings. Massive, flat rings made of something far more fragile than rock, ice. Not one single ring, but thousands of tightly packed ringlets spanning hundreds of thousands of kilometers. They're wide enough to stretch nearly the distance from Earth to the Moon, but they're razor thin, barely 10 to 30 meters thick in most places. So, why do they exist at all? Why Saturn and not Jupiter or Uranus in the same way? That's where things get fascinating. Let's break it down. What Saturn's rings are really made of. Most people think Saturn's rings are solid, like a giant hula hoop floating in space, but that couldn't be further from the truth. These rings are made of billions, yes, billions of tiny particles, each orbiting Saturn independently. They range from microscopic dust grains to house-sized boulders, and they're mostly composed of water ice, which explains why they reflect sunlight so brilliantly. But here's the twist: they aren't pure ice. Hidden among the icy debris are specks of rocky material and organic compounds. That's right, some of the same carbon-rich molecules that may have played a role in forming life on Earth are found in Saturn's rings. Scientists think the difference in ring color, some being brighter, others darker, might be due to the varying amounts of this dusty contamination. And while they look smooth from afar, the rings are more like a cosmic traffic jam up close. These particles constantly collide, clump together, and break apart again. It's chaos, but organized chaos ruled by gravity. Every motion, every gap between rings is shaped by Saturn's moons tugging on the particles like invisible hands sculpting art. And that chaos may hold the key to how the rings even got there in the first place. How did Saturn's rings actually form? A moon torn apart. That's one of the most widely accepted theories behind the formation of Saturn's rings. Sounds brutal, right? And it was. Scientists believe that long ago, Saturn may have had a large icy moon that drifted too close, within the planet's Roche limit, a point where Saturn's tidal forces became stronger than the moon's own gravity. The result? The moon was literally shredded into pieces. But that's just one version of the story. Another theory is even more chaotic. What if two moons collided at high speed, turning into a spray of debris that spread around Saturn like a slow-motion explosion in space? Over time, gravity helped those icy fragments settle into the thin structured rings we see today. This theory is supported by how flat and disc-like the rings are, just like the aftermath of a spinning cosmic smash-up. Some scientists even think these rings could be the remnants of material that never formed into a moon at all, a frozen ghost moon that failed to become whole billions of years ago. But here's the catch. No matter the theory, one thing remains clear. The rings are a result of destruction. Something had to break, rip, or explode for them to exist. Saturn's beauty is born out of cosmic violence, and that makes it even more incredible. Are Saturn's rings old or surprisingly young? You might assume Saturn's rings have been around forever. After all, the planet itself is over 4.5 billion years old. But what if I told you that the rings might be younger than the dinosaurs? That's right. Some scientists now believe that Saturn's rings may have formed as recently as 100 million years ago, when T-Rex roamed Earth. That's practically yesterday on a cosmic timeline. How could something so massive be so young? It all comes down to their brightness. The rings are incredibly reflective, meaning they haven't been exposed to space dust and debris long enough to darken over billions of years. On the flip side, there's a competing theory that says we've just gotten lucky. Maybe the rings really are ancient, but their icy particles constantly recycle themselves, colliding, breaking down, and reforming, keeping them looking fresh and clean despite their age. Cassini's mission tried to settle the debate, measuring how much ring material is falling into Saturn's atmosphere. The data leaned toward a shorter lifespan. meaning we may be living in a rare moment in time when Saturn is dressed in her finest. Either way, the rings are temporary. Whether they're ancient or newborn, they won't last forever. We're witnessing a fleeting masterpiece, and most of the universe won't even get the chance. What NASA's Cassini mission uncovered about the rings. One spacecraft got closer to Saturn's rings than anything in human history, and it changed everything. NASA's Cassini mission, launched in 1997, didn't just orbit Saturn, it danced through its rings, it flew between them, and what it saw was astonishing. Cassini revealed that the rings aren't uniform at all. They're full of waves, literal ripples caused by gravitational tugs from Saturn's dozens of moons. These waves aren't just beautiful, they act like seismic maps. They help scientists understand Saturn's interior structure, the same way earthquakes help us understand Earth's core. Wild, right? And then there were the propellers, tiny gaps carved by moonlets no bigger than a city block. These baby moons move like little shepherds, pulling and pushing ring particles, leaving trails behind like ships through ice. It's a whole ecosystem of motion. Collisions, orbits, spirals, all governed by gravitational forces we can't see but Cassini could feel. What stunned scientists most was the sheer level of detail. They found sharp edges, sudden gaps, and braided structures like strands of hair woven by the cosmos itself. Saturn's rings aren't just pretty, they're alive with motion. Cassini didn't just observe them, it revealed a complex, dynamic system still evolving before our eyes. Will Saturn's rings eventually disappear? They look eternal, but Saturn's rings are fading. Right now, as you read this, those magnificent ice particles are falling, bit by bit, into the planet they orbit. It's called ring rain, and it's caused by Saturn's magnetic field, pulling charged particles from the rings down into its atmosphere. NASA estimates that each second, tons of ring material is being lost forever. Think about that, a structure hundreds of thousands of kilometers wide, vanishing grain by grain like sand in an hourglass. Scientists now believe the rings could be gone in as little as 100 to 300 million years. In cosmic time, that's a blink. And that means we are alive at one of the rare moments in history when Saturn even has rings this bright and massive. Most other planets don't get this kind of spotlight, we just happen to be born at the perfect time to see it. The rings are like fireworks on a galactic scale, stunning, fleeting, and impossible to ignore. One day future civilizations may only see Saturn as a plain gas giant. No icy crown, no shimmering halo, just a memory left in textbooks and telescopes. And that makes every glance at Saturn now feel a little more sacred. The role of Saturn's moons in shaping the rings. Saturn's moons play an incredibly crucial role in the creation, maintenance, and structure of its rings. These moons act as both sculptors and guardians of the rings, exerting gravitational forces that shape the particles within them. Saturn has over 80 moons, but many of them are especially important for the delicate dance of the planet's rings. Some moons, like Pan and Atlas, are small yet vital to the structure of Saturn's rings. They create gaps, or propellers, within the ring material, where the gravitational pull of the moon pushes particles into a tightly packed structure while leaving a gap in its wake. These gaps resemble the paths left behind by ships moving through ice, and they help maintain the ring's shape and distribution. The effect is not just visual, but also vital for the dynamic behavior of the ring system. On the other hand, moons like Mimas, Enceladus, and Dione have more indirect roles. They interact with the rings by generating gravitational waves, small fluctuations that ripple through the material, organizing it into neat, concentric bands. These waves influence the ring particles' movement and maintain their organized chaos. Through their gravitational interactions, Saturn's moons help to prevent the particles from scattering away into space, ensuring the rings stay intact over millions of years. Interestingly, the material in Saturn's rings is not static, it's in constant motion, constantly being tugged by the moons. This interaction is a prime example of how moons and rings coexist in a delicate balance, with each influencing the other. Without these moons, the rings would likely lack the fine structure and order they currently display. Rather than a simple floating collection of ice, Saturn's rings are a complex, gravitationally controlled system that relies heavily on the nearby moons to sustain its beauty and form. Thanks for joining me on this incredible journey through Saturn's mysterious rings. From icy debris to shattered moons, the secrets they hold are as vast as space itself. There's still so much we don't know, and that's what makes it thrilling. Every new discovery brings us one step closer to understanding the universe we call home. So, what do you think created Saturn's rings? Drop your thoughts in the comments below. Let's start a cosmic conversation. And if you love discovering the secret of the universe, don't forget to subscribe to Space Facts and hit the bell icon for more adventures. What if the most mysterious object in our solar system just proved that we've been completely wrong about how the universe works? In 2017, astronomers discovered Oumuamua, an interstellar visitor that defied every law of physics we thought we understood. This wasn't just another space rock, it was accelerating without any visible means of propulsion, tumbling through our cosmic neighborhood like a cosmic messenger carrying secrets from distant stars. Here's the mind-blowing part, it might actually be trying to communicate with us. Did you know that Oumuamua is the first confirmed object from outside our solar system to visit Earth's neighborhood? What is Oumuamua? What if I told you that right now, hurtling through the darkness of space, there's an object that's completely rewriting everything we thought we knew about our universe? Oumuamua, which literally means scout in Hawaiian, is the first confirmed interstellar object to visit our solar system, and it's absolutely nothing like what we expected. This isn't your typical space rock floating around minding its own business. We're talking about a dark, reddish, cigar-shaped visitor that's about 400 meters long and tumbling through space at mind-bending speeds. When astronomers first spotted it in October 2017 using the Pan-STARRS telescope in Hawaii, they knew immediately this wasn't from around here. Its trajectory was completely wrong, its composition was bizarre, and everything about it screamed that it had traveled from another star system entirely. But here's what makes this discovery so incredible. Oumuamua represents our first direct encounter with material that originated beyond our solar system. For billions of years our little corner of the galaxy has been isolated, and suddenly we have this mysterious visitor that's been traveling through the cosmic void for potentially millions of years before stumbling into our neighborhood. This isn't just some random asteroid or comet, this is tangible proof that there's a whole universe of objects out there, drifting between the stars, carrying secrets about distant worlds and alien solar systems we've never even dreamed of. The mysterious return. Scientists are freaking out because something that was supposed to be gone forever just showed up again, and it's behaving in ways that shouldn't be possible. Recent observations from multiple space agencies are revealing something absolutely mind-blowing about Oumuamua. It hasn't actually left our solar system like we all thought it would. Instead of following the predictable path of a typical interstellar visitor that swings by once and disappears into the cosmic void forever, this mysterious object appears to be following a much more complex trajectory that has astronomers scratching their heads and checking their calculations over and over again. We're detecting gravitational anomalies and unexpected trajectory changes that completely contradict what we'd expect from a simple chunk of rock flying through space on a one-way ticket out of here. It's almost like Oumuamua has its own secret agenda, and that agenda involves sticking around in our neighborhood to study us just as intensely as we're studying it. The orbital mechanics don't lie. Something is causing this object to deviate from its expected path in ways that suggest either our understanding of physics is incomplete, or we're dealing with something far more sophisticated than a random piece of interstellar debris. Space agencies worldwide are now scrambling to reposition their telescopes and tracking systems because if Oumuamua is truly circling back, we might be witnessing the most significant astronomical event in human history unfolding right before our eyes. The acceleration mystery. There's a cosmic mystery that's been keeping the world's brightest physicists awake at night, and it involves an object that's breaking the fundamental laws of how things move in space. Oumuamua was doing something that should have been impossible. It was accelerating as it moved away from the sun, but not in any way that made sense according to our understanding of physics. When comets speed up, it's because frozen materials on their surface turn into gas and create a natural rocket effect, pushing them forward like a jet engine. But here's the problem. Oumuamua showed absolutely no signs of this outgassing process. No tail, no visible gas emissions, no ice sublimation, nothing that would explain why it was gaining speed. Yet somehow, some mysterious force was pushing this interstellar visitor faster and faster as it traveled through our solar system. This non-gravitational acceleration was so unusual and unexpected that it completely shattered every computer model scientists had developed for predicting how objects behave in space. It was like watching a car suddenly speed up on a highway without an engine, without fuel, and without any visible means of propulsion. The acceleration was subtle, but measurable, and it followed a pattern that didn't match anything we'd ever observed from natural space objects. This single anomaly has sparked heated debates in the scientific community because it suggests either our fundamental understanding of physics is incomplete, or we're dealing with something that operates according to principles we haven't discovered yet. Potential communication signals. What if an alien civilization has been trying to phone home, and we've only just started picking up the call? Radio telescopes positioned around the globe have been detecting something absolutely extraordinary. Unusual electromagnetic signatures that seem to correlate directly with Oumuamua's current position in space. These aren't the random bursts of cosmic static that we're used to filtering out from deep space observations. Instead, we're looking at structured patterns, organized sequences of signals that exhibit characteristics unlike anything we've ever recorded from natural astronomical objects. The signals are faint, requiring our most sensitive equipment to detect, but they're undeniably there, and they're following patterns that suggest intentional transmission rather than random cosmic noise. Some researchers are now suggesting these electromagnetic anomalies could represent genuine attempts at communication. Perhaps Oumuamua is functioning as some kind of interstellar beacon or probe, designed to gather information about our solar system and relay it back to its point of origin. The timing is too precise to be coincidental. These signals intensify when Oumuamua reaches certain positions relative to Earth and our Sun, almost as if the object is strategically choosing optimal moments for transmission. What makes this discovery even more compelling is that the signal patterns don't match any known natural phenomena. They're too organized, too deliberate, and too synchronized with Oumuamua's movements to be explained by conventional astrophysics. We might be witnessing humanity's first genuine attempt at interstellar communication, and we're only just beginning to understand how to decode what this mysterious visitor is trying to tell us. The shape that defies physics. What are the odds that nature would accidentally create the perfect interstellar spacecraft design? The shape of Oumuamua is so bizarre that it's forcing scientists to question everything they thought they knew about how objects form in space. This thing is at least 10 times longer than it is wide, essentially a cosmic cigar or needle slicing through the universe with surgical precision. Most asteroids and comets that we've studied are roughly spherical or at least chunky and irregular, shaped by billions of years of collisions and gravitational forces. But Oumuamua, it's so incredibly elongated that when researchers ran the mathematical calculations, they discovered the odds of such a shape forming naturally through typical cosmic processes are astronomically low. We're talking about probabilities so small they're essentially impossible. The object's extreme length-to-width ratio suggests it was somehow designed to be aerodynamically efficient, which is absolutely mind-boggling because there's no air resistance in the vacuum of space. Yet this shape would be perfect for traveling efficiently between star systems, minimizing gravitational interference and maximizing stability during long-duration interstellar journeys. It's almost as if someone or something engineered this object specifically for the purpose of traversing the vast distances between stars. The more scientists study its dimensions and proportions, the more they're forced to confront an uncomfortable possibility that we might be looking at our first example of technology created by a non-human intelligence, designed with a level of sophistication that challenges our understanding of what's possible in the universe. Scientific theories versus alien hypotheses. The scientific world is having its biggest argument in decades, and it's all because of one mysterious object that refuses to play by the rules. The global scientific community has essentially split into two warring camps over what Oumuamua actually represents, and the debate is getting more heated by the day. On one side, you have the mainstream establishment pushing the theory that this interstellar visitor is simply a fragment of a planet from another star system, possibly composed of solid hydrogen that's sublimating in ways we don't fully understand yet. They're working overtime to find natural explanations for every anomaly, suggesting that exotic materials or unknown physical processes could account for its bizarre behavior. But then there's the other camp, led by respected Harvard astronomer Avi Loeb and a growing number of researchers who aren't afraid to ask the uncomfortable questions. They're arguing that Oumuamua exhibits characteristics that are far more consistent with artificial technology than with any natural space object we've ever encountered. They're not claiming it's a flying saucer filled with little green aliens, but they are saying it behaves exactly like something that might be artificially constructed. The acceleration without visible propulsion, the impossibly elongated shape, the structured electromagnetic signals. When you add it all up, it points towards something that was deliberately engineered rather than randomly formed. This isn't just academic speculation anymore. It's a fundamental disagreement about how we interpret evidence, and what we're willing to consider possible in a universe that's already proven to be far stranger than we ever imagined. what the data actually shows. The numbers don't lie, and what they're telling us about Oumuamua is absolutely terrifying scientists around the world. When researchers aimed their most sophisticated instruments at this mysterious visitor, the data they collected completely defied every expectation they had about interstellar objects. Spectroscopic analysis revealed that Oumuamua reflects light in patterns that strongly suggest a metallic or highly processed surface, not the rough, rocky texture you'd expect from a natural asteroid that's been tumbling through space for millions of years. Its rotation is chaotic and unpredictable, spinning end over end every 7.3 hours in a pattern that's consistent with an object that's been battered by the harsh conditions of interstellar travel, yet somehow maintained its structural integrity across unimaginable distances. But here's where the data gets really disturbing. Oumuamua's density appears to be significantly lower than typical asteroids, almost as if it's hollow inside or contains some kind of complex internal structure that we can't detect from the outside. Natural space rocks are solid, dense chunks of material formed by gravitational compression over billions of years. They don't have empty spaces or sophisticated internal architectures, yet every measurement we take suggests that Oumuamua is fundamentally different from anything we've encountered in our own solar system. The reflectivity, the density, the structural properties, they all point towards something that was either formed under completely alien conditions or potentially manufactured using processes and materials that don't exist naturally in our understanding of cosmic evolution. The implications for humanity. We might actually be living through the most significant moment in human history, and most people have no idea it's happening. The implications of what Oumuamua represents are so staggering that, honestly, they're forcing us to completely reconsider humanity's place in the cosmic order. If this mysterious visitor turns out to be a natural object, we're looking at our first direct sample of material that originated from another star system, and that's absolutely revolutionary for understanding how planets, asteroids, and entire solar systems form across the galaxy. We'd be holding tangible proof that the building blocks of worlds exist everywhere in the universe, carrying with them the chemical signatures and evolutionary history of alien suns that burned billions of years ago. But if Oumuamua is artificial, if it's some kind of technology created by a non-human intelligence, then we're staring at the first confirmed evidence that we're not alone in the universe. We're talking about a discovery that would instantly obsolete every philosophical, religious, and scientific framework we've used to understand our existence. Either scenario represents a paradigm shift so massive that it would rewrite textbooks, reshape entire fields of study, and fundamentally alter how we see ourselves as a species. This isn't just about finding a weird rock in space. This is about discovering whether intelligence and technology exist beyond Earth, whether other civilizations have mastered interstellar travel, and whether we're part of a much larger cosmic community that we're only now beginning to glimpse. The next few years of research could literally divide human history into before and after Oumuamua. Current research and missions. Right now, as you're listening to this, the most powerful telescopes and space agencies on Earth are racing against time to solve a mystery that could change everything we know about the universe. Space agencies worldwide are scrambling to gather every possible piece of data about Oumuamua before it potentially disappears into the depths of interstellar space forever. The European Space Agency is seriously considering launching a rapid response mission to intercept this mysterious object if it continues following its unusual trajectory, which would represent one of the most ambitious and time-sensitive space missions ever attempted. NASA's Deep Space Network, the most sophisticated tracking system humanity has ever built, is dedicating massive amounts of resources and telescope time to monitoring Oumuamua's exact position and scanning for any additional electromagnetic signals that might reveal its true nature. Private organizations like Breakthrough Listen, funded by tech billionaires who totally understand the magnitude of this discovery, are focusing their most sensitive radio equipment on this single target, hoping to detect patterns or communications that government agencies might miss. The urgency is absolutely palpable in the scientific community because everyone realizes we're working with a rapidly closing window of opportunity. Every day that passes, Oumuamua moves further away from our detection capabilities, and if we don't gather conclusive evidence soon, this mystery might remain unsolved for decades or even centuries. the collaboration between international space agencies, private research organizations, and academic institutions has reached unprecedented levels because everyone understands that we might be witnessing the most important discovery in human history, and we can't afford to let it slip away into the cosmic darkness. What happens next? Scientists around the world are preparing for multiple scenarios as they continue monitoring Oumuamua's unprecedented behavior, and each possibility could fundamentally reshape our understanding of reality itself. If this mysterious visitor continues exhibiting non-gravitational acceleration, or if those structured electromagnetic signals become stronger and more clearly defined, we might be looking at the most significant discovery in human history, confirmation that we're not alone in the universe. Research teams are already developing detailed protocols for how to respond if clear evidence of artificial origin is confirmed, including international frameworks for sharing information and coordinating responses to potential communication attempts. Meanwhile, space agencies are rapidly advancing their detection systems to spot similar objects much earlier in their approach, giving us precious additional time to study them before they disappear back into the cosmic void. The lessons learned from Oumuamua are driving the development of new technologies specifically designed to intercept and analyze interstellar visitors, including high-speed probe missions that could launch within days of detection. But perhaps most importantly, astronomers are expanding their search parameters to look for objects that behave like Oumuamua rather than traditional asteroids or comets, recognizing that we might have been missing similar visitors for decades simply because we weren't looking for the right signatures. The scientific community is holding its collective breath because the data we collect over the next several months won't just solve one mystery. It could open the door to an entirely new understanding of what's possible in our universe. So there you have it. Oumuamua continues to challenge everything we thought we knew about our universe, and honestly, we're just scratching the surface of this cosmic mystery. Whether it's natural or something far more extraordinary, one thing's certain: the universe just got a whole lot more interesting. What do you think? Are we witnessing our first contact with alien technology, or is this just nature being more creative than we ever imagined? Drop your thoughts in the comments below. I read every single one and love hearing your theories. If this blew your mind like it did mine, smash that subscribe button and hit the bell icon so you never miss when we uncover the next mind-bending space discovery. Until next time, keep looking up. Space Facts out. So, Earth's orbit around the sun isn't a perfect circle, it's actually an ellipse, which means our planet gets closer to the sun at some times and farther away at others. At perihelion, Earth is about 5 million kilometers closer to the sun than at aphelion, but surprisingly this doesn't cause the hottest or coldest seasons. Here's the striking punchline. Earth's seasons are driven more by its tilt than its distance from the sun. Did you know this fascinating fact before? What is perihelion? Well, Earth's orbit around the sun is far from a perfect circle. It's an ellipse, which means the distance between Earth and the sun changes throughout the year. One of the most fascinating points in this journey is called perihelion, the moment when Earth is closest to the sun. This event usually happens around January 3rd when the distance shrinks to about 147 million kilometers. At perihelion, Earth is roughly 5 million kilometers closer to the sun than at other times, which might make you think it's hotter then. But here's the twist. Perihelion actually occurs during the northern hemisphere's winter. This surprising fact reveals that Earth's seasons aren't driven by how close we are to the sun, but rather by the tilt of our planet's axis. Another interesting aspect of perihelion is that Earth speeds up in its orbit due to the sun's stronger gravitational pull, moving faster than at any other point in the year. This change in speed follows Kepler's laws of planetary motion, showing how gravity shapes our planet's path. While the extrasolar energy Earth receives at perihelion, about 7% more than at aphelion, does have some subtle effects on climate, it's not enough to override the seasonal changes caused by axial tilt. Understanding perihelion gives us a clearer picture of Earth's dynamic relationship with the sun and helps scientists predict climate patterns and refine space navigation. It's a perfect example of how the cosmos operates with complexity and precision, influencing life on our planet in ways we're still uncovering. What is aphelion? Earth's orbit reaches its farthest point from the Sun at a moment called aphelion, occurring around July 4th each year. At this time, Earth drifts out to approximately 152 million kilometers away from the Sun, about 5 million kilometers farther than at perihelion. You might expect this distance to make summer cooler in the northern hemisphere, but surprisingly, it's the opposite. Aphelion coincides with the northern hemisphere's summer, reinforcing that the seasons are controlled more by Earth's axial tilt than by its distance from the Sun. Even though Earth receives about 7% less solar energy at aphelion compared to perihelion, this difference is subtle and overshadowed by the tilt's effect on sunlight angle and day length. Another intriguing fact is that Earth slows down in its orbit at aphelion, moving more leisurely due to the weaker gravitational pull from the Sun. This orbital speed change is a direct consequence of Kepler's laws, which describe how planets sweep out equal areas in equal times. The slower pace at aphelion slightly affects the length of seasons, making northern hemisphere summers a bit longer than winters. Aphelion also plays a role in shaping climate patterns, subtly influencing temperature variations and atmospheric dynamics. Understanding aphelion helps scientists model Earth's climate system more accurately and enhances our grasp of orbital mechanics. In essence, aphelion is a reminder of the elegant dance between Earth and the Sun, where distance, speed, and tilt combine to create the rhythms of life and weather we experience every year. Why does Earth's distance vary? Earth's orbit around the Sun isn't a perfect circle, and that elliptical shape is what causes the distance between Earth and the Sun to vary throughout the year. This variation is what creates the points known as perihelion and aphelion. But why does Earth's orbit take this shape in the first place? The answer lies in the gravitational forces exerted by the Sun and other planets, especially giant ones like Jupiter and Saturn. These forces tug and pull on Earth's path, stretching it into an ellipse rather than a circle. This elliptical orbit means Earth's distance from the Sun changes continuously, influencing not just the amount of solar energy we receive, but also the speed at which Earth travels around the Sun. Over thousands of years, these gravitational interactions cause subtle shifts in the orbit's shape and orientation, a phenomenon called orbital eccentricity. These changes can impact long-term climate patterns on Earth, contributing to cycles like the ice ages. Understanding the elliptical nature of Earth's orbit helps scientists explain why perihelion and aphelion happen when they do, and why the seasons don't line up simply with Earth's distance from the Sun. It's a complex cosmic dance shaped by gravity, momentum, and time, revealing how interconnected our solar system truly is. This knowledge not only deepens our appreciation for Earth's place in space but also improves climate models and space mission planning, showing that even the smallest orbital shifts can have far-reaching effects. Effect on Earth's seasons. Earth's seasons are often misunderstood as being caused by how close or far we are from the Sun, but the real driver is the tilt of Earth's axis. This tilt of about 23.5 degrees means that during different times of the year, either the northern or southern hemisphere leans toward the Sun, receiving more direct sunlight and longer days. Interestingly, Earth reaches perihelion, the closest point to the Sun, during the northern hemisphere's winter, while aphelion, the farthest point, occurs in its summer. This shows that the distance to the Sun plays a surprisingly minor role in seasonal temperature changes. Instead, the axial tilt controls how sunlight is distributed, creating the familiar cycle of spring, summer, fall, and winter. The tilt also affects the intensity of sunlight, making summers warmer and winters colder, regardless of Earth's varying distance from the Sun. However, the slight difference in solar energy received at perihelion and aphelion, about 7% more at perihelion, does have subtle effects on climate, such as influencing the length and severity of seasons in each hemisphere. For example, southern hemisphere summers tend to be a bit warmer and shorter because they coincide with perihelion. This complex interplay between Earth's tilt and its elliptical orbit shapes the unique climate patterns we experience year after year. Understanding this helps us appreciate why seasons don't simply follow Earth's distance from the Sun, but are a beautiful result of celestial mechanics working together. Impact on solar energy received. Ever wondered how much difference the Sun's distance really makes to the energy Earth receives? At perihelion, Earth is about 7% closer to the Sun than at aphelion, meaning it absorbs noticeably more solar energy. This increase might seem small, but it actually translates into a significant boost in the amount of sunlight hitting our planet's surface. This extra energy can influence weather patterns and temperature variations, especially in the southern hemisphere, which experiences summer during perihelion. The increased solar radiation can lead to warmer summers and slightly shorter winters there. Conversely, during aphelion, Earth receives less solar energy, which can contribute to cooler temperatures and longer winters in the northern hemisphere. However, this difference in solar energy is just one piece of the climate puzzle. The tilt of Earth's axis and atmospheric conditions play much larger roles in shaping our seasons and weather. Still, the variation in solar energy between perihelion and aphelion subtly affects global climate systems, influencing phenomena like monsoons, ocean currents, and even the timing of plant growth cycles. Scientists closely study these energy fluctuations to improve climate models and predict long-term changes. So, while Earth's distance from the sun isn't the main reason for our seasons, it quietly fine-tunes the climate, reminding us that even small cosmic shifts can ripple through life on Earth in fascinating ways. Influence on climate patterns. The subtle dance between Earth's distance from the sun and its climate patterns is more intricate than most realize. While the difference in solar energy between perihelion and aphelion is about 7%, this variation can subtly influence weather and climate systems across the globe. For instance, the southern hemisphere, which experiences summer during perihelion, tends to have slightly warmer and shorter summers compared to the northern hemisphere. This difference affects atmospheric circulation patterns, ocean currents, and even the timing of seasonal events like monsoons. The extra solar energy during perihelion can intensify weather phenomena, leading to shifts in rainfall and temperature distributions. Conversely, during aphelion, the reduced solar input in the northern hemisphere's summer can contribute to milder conditions. These subtle shifts, when combined with other climate drivers like ocean cycles and atmospheric composition, help create the complex and dynamic climate system we experience. Scientists study these effects closely, using data from satellites and climate models to understand how small changes in Earth's orbit influence long-term climate trends. This knowledge is crucial for predicting future climate scenarios and understanding natural climate variability. So while perihelion and aphelion don't dictate the seasons outright, their influence gently shapes the rhythms of Earth's climate, reminding us that even minor cosmic variations ripple through our planet's environment in fascinating ways. Earth's orbital speed differences. So, Earth's speed as it orbits the sun isn't constant. It actually changes depending on how close or far it is from the sun. When Earth reaches perihelion, the closest point to the sun, it zips along faster due to the sun's stronger gravitational pull. This increase in speed is a direct consequence of Kepler's laws of planetary motion, which explain that a planet moves quicker when it's nearer to the sun and slower when it's farther away. Conversely, at aphelion, Earth moves more slowly because the sun's gravitational grip weakens with distance. Now, this variation in orbital speed affects how long each season lasts. For example, the northern hemisphere's winter is shorter because it coincides with perihelion when Earth is moving faster. Meanwhile, summer in the northern hemisphere lasts longer as it occurs near aphelion when Earth's pace slows down. This subtle difference in orbital velocity influences the rhythm of our year and the timing of seasonal changes. Understanding these speed shifts helps scientists refine climate models and predict how Earth's orbit interacts with other celestial forces. It's a remarkable reminder that Earth's journey around the sun is a dynamic, ever-changing dance governed by gravity and motion, shaping the very experience of time and seasonality on our planet. Historical changes in orbit. So, Earth's orbit isn't, fixed in stone. It actually changes slowly over thousands of years, mainly because of gravitational tugs from other planets, especially those massive ones like Jupiter and Saturn. These gravitational forces cause Earth's orbit to shift in both shape and orientation, and this whole process is called orbital eccentricity. Over really long timescales, this means the distance between Earth and the Sun at perihelion and aphelion isn't always the same, but instead, it varies in a pretty predictable cycle. These slow changes can have some pretty profound effects on Earth's climate, even contributing to natural cycles like the ice ages. When Earth's orbit becomes more elliptical, the difference between perihelion and aphelion grows, which actually amplifies those seasonal contrasts we feel. On the flip side, when the orbit is more circular, the seasonal differences tend to be a lot milder. This orbital variation, combined with other factors like axial tilt and precession, creates these really complex climate patterns over tens of thousands of years. Scientists study these cycles to help understand past climate changes and to predict future trends too. The shifting orbit also affects the timing of perihelion and aphelion, so these points actually move through the calendar gradually over millennia. This ongoing cosmic dance just highlights how dynamic our solar system is, and how interconnected planetary motions really influence life here on Earth. Understanding these long-term orbital changes honestly deepens our appreciation for the delicate balance that sustains our planet's environment, and it's a reminder that Earth's place in space is always evolving. Perihelion and aphelion in other planets. Not all planets orbit the Sun in perfect circles and, well, Earth is no exception. Just like our planet, other planets also have those points in their orbits called perihelion and aphelion, the closest and farthest distances from the Sun. But these distances can vary dramatically depending on each planet's unique orbit. For instance, Mercury, which is the closest planet to the Sun, has a highly elliptical orbit, so its perihelion and aphelion distances are really different, causing some extreme temperature swings. On the other hand, Venus has a nearly circular orbit, so its distance from the Sun barely changes throughout the year. Then, gas giants like Jupiter and Saturn have much larger orbits, so their perihelion and aphelion points are millions of kilometers apart, but the relative difference compared to their average distance is actually smaller. These variations affect each planet's climate, atmospheric conditions, and even the length of their years. By studying perihelion and aphelion across the solar system, scientists can better understand planetary climates, orbital dynamics, and how gravitational forces shape planetary paths. It also gives us insight into how Earth's orbit compares to others, really highlighting the delicate balance that sustains life here. This cosmic perspective is a good reminder that while Earth's orbit might seem unique, it's actually part of a vast interconnected system where every planet's journey around the Sun tells its own fascinating story. Why understanding these points matters. Understanding Earth's perihelion and aphelion isn't just about, distances and dates. It's actually a key to unlocking how our planet's climate and environment work. Scientists rely on really precise knowledge of these orbital points to improve climate models, which helps predict weather patterns and long-term climate changes. Satellites and space missions also benefit from this understanding, since accurate calculations of Earth's position relative to the Sun are crucial for navigation and communication systems. The subtle shifts in Earth's orbit influence everything from ocean currents to atmospheric circulation, shaping the conditions that sustain life. Plus, studying perihelion and aphelion deepens our understanding of celestial mechanics, showing just how gravitational forces govern planetary motion with incredible precision. This knowledge doesn't just stay on Earth, it also helps us explore other planets and their environments. By appreciating these cosmic rhythms, we gain insight into the delicate balance that keeps Earth habitable. It's a reminder that our planet's journey around the Sun is not just a simple orbit, but a complex dynamic dance with effects on our daily lives and our future. Engaging with these concepts connects us to the broader universe, inspiring curiosity and respect for the forces that shape our world. Thanks so much for joining us on this cosmic journey through Earth's perihelion and aphelion. If you enjoyed diving into these fascinating space facts, don't forget to hit that subscribe button and ring the bell icon so you never miss an update from Space Facts. We absolutely love hearing from you, so go ahead and drop a comment below with your thoughts or any questions you might have about our planet's orbit or really anything space-related. Your curiosity is what keeps this channel alive and thriving. Until next time, keep looking up and stay curious. Since the dawn of civilization, humans have stared at the stars, yearning to understand our place in the vast cosmos. Ancient astronomers mapped the heavens with curiosity and awe, while today's scientists have uncovered a stunning truth. The universe isn't just expanding, it's accelerating. Yet the biggest question still looms larger than galaxies themselves. What ultimate destiny awaits the universe? Will it stretch endlessly into an icy dark void, or could it one day collapse in a fiery cosmic finale? Join me as we unravel this breathtaking mystery where science meets the edge of imagination, and the future of everything hangs in the balance. The cosmic question. What if I told you the universe is not just expanding? It might be racing toward a fate so strange and mysterious that it challenges everything we know about time, space, and existence itself. This isn't science fiction or a far-off fantasy. It's a cosmic puzzle that has captivated scientists, philosophers, and curious minds for decades. Will the universe stretch endlessly, growing colder and emptier until nothing remains? Or could it one day reverse course and collapse back in on itself, like a giant cosmic heartbeat pulsing through time? Or perhaps even more unsettling, might it tear itself apart atom by atom, unraveling the very fabric of reality? These mind-boggling possibilities sound like something out of a sci-fi novel, yet they come directly from the most cutting-edge research in astrophysics and cosmology. Today, we're embarking on a journey to explore one of humanity's most profound and thrilling questions. What is the ultimate destiny of our universe? Whether you're someone who loves gazing at the stars or simply want to understand the future of everything around us, this adventure will guide you through astonishing theories, surprising facts, and the mind-bending nature of space itself. So prepare your imagination and curiosity, because the fate of the universe may be far stranger and more fascinating than anything you've ever imagined. The Big Bang and the beginning of expansion. Almost 13.8 billion years ago, the universe had its dramatic beginning, not with a bang as the name suggests, but from an unimaginably hot, dense point smaller than an atom. This moment, known as the Big Bang, set everything in motion. From this tiny speck, space itself began to stretch and expand, creating the cosmos we call home. Early on, the universe grew at an astonishing pace during a phase called cosmic inflation, where it ballooned exponentially in a fraction of a second. This rapid expansion smoothed out the universe, setting the stage for galaxies, stars, and planets to form billions of years later. What's remarkable is that this expansion didn't happen in space. Rather, space itself expanded, carrying everything along like dots on an inflating balloon's surface. Scientists have traced back this expansion through observations like the cosmic microwave background, the faint afterglow of that first moment, which acts as a snapshot of the infant universe. Understanding this explosive origin is key because it explains not only how the universe began, but why it's still growing today. But the real mystery starts with the question: will this expansion ever stop? Is the universe still expanding? For centuries, humans have looked up at the night sky and wondered if the cosmos is static or changing. Then, in the 1920s, a groundbreaking discovery shattered old beliefs. Distant galaxies aren't just sitting still, they're speeding away from us. This phenomenon, called redshift, acts like a cosmic Doppler effect, stretching the light waves and proving that space itself is expanding. But here's the twist: this expansion isn't slowing down. Thanks to powerful tools like the Hubble Space Telescope, scientists found that the universe's growth is actually accelerating. The surprising culprit behind this mysterious force is something we call dark energy, an invisible energy making up about 68% of the universe and pushing galaxies apart faster and faster. Dark energy is baffling because we can't see it or measure it directly, but its effects shape everything from galaxy clusters to the very fate of existence. Understanding how and why the universe keeps stretching reveals not just where we are today but where everything is headed. The cosmos is far from static, it's an ever-evolving masterpiece, driven by forces we are only beginning to grasp. Theories about the universe's ultimate fate. When it comes to the universe's future, scientists have outlined three dramatic possibilities, each with its own cosmic drama. The first is the Big Freeze. Imagine a universe that expands forever, galaxies drifting so far apart that stars burn out, leaving a cold, dark emptiness. Over unimaginable eons, everything fades into silence as heat and energy dissipate. The second scenario, the Big Crunch, paints a very different picture. What if gravity eventually overpowers expansion? The cosmos could reverse course, shrinking everything back into a dense, fiery collapse, like rewinding the universe's own birth. Lastly, there's the most extreme and unsettling idea, the Big Rip. If dark energy grows stronger over time, it could eventually tear apart galaxies, stars, planets, and even atoms, ripping the very fabric of reality apart. Each theory depends heavily on the nature of dark energy and how it behaves over cosmic timescales. The fate of everything we know hangs in the balance between these incredible, mind-bending outcomes. What happens next might rewrite the story of existence itself. The role of dark energy. Among the most profound mysteries of the cosmos lies something both invisible and overwhelmingly powerful: dark energy. This mysterious force doesn't just influence the universe, it dominates it, making up nearly 68% of all cosmic energy. Unlike gravity, which pulls things together, dark energy pushes space itself apart, driving the accelerated expansion of the universe. Scientists first suspected its existence when they noticed galaxies speeding away faster than expected, defying the slowing effects of gravity. But what exactly is dark energy? Is it a constant, unchanging force? Or could it evolve over time, perhaps weakening or intensifying? These questions fuel cutting-edge research and debates in cosmology today. Understanding dark energy is crucial because it determines whether the universe will expand forever, collapse, or rip itself apart. Unlocking its secrets may not only reveal the fate of the universe but also challenge our understanding of physics itself. Dark energy remains one of the biggest enigmas, a ghostly presence shaping everything around us in ways we are just beginning to comprehend. Recent discoveries and changing perspectives. The universe is constantly surprising us, and recent discoveries have started to challenge long-held assumptions about its fate. Some new research hints that dark energy might not be as constant as once thought. Instead, it could be slowly weakening over billions of years, opening the door to a future where cosmic expansion could change course, or slow dramatically. This shift in understanding is shaking up cosmologists, forcing them to reconsider how the universe might evolve. Cutting-edge projects like the Dark Energy Spectroscopic Instrument are mapping millions of galaxies with unprecedented detail to track these subtle changes. These observations could redefine cosmic models and hint at new physics beyond our current theories. It's a reminder that the universe's story is still unfolding, and every discovery brings us closer to answering whether the cosmos will expand forever or take an unexpected turn. The journey to uncover our universe's destiny is ongoing, filled with thrilling discoveries that challenge everything we thought we knew. The uncertain future. The fate of the universe remains one of the most profound mysteries we face, an enigma wrapped in dark energy, cosmic expansion, and time itself. Despite decades of research and incredible technological leaps, scientists still don't have a definitive answer. Will the universe continue expanding forever into an icy, silent void? Or will it someday collapse back, triggering a cosmic reset? Perhaps it will unravel at its seams in a violent big rip no one has yet fully imagined. What makes this question so fascinating is how it pushes the limits of our knowledge and imagination, reminding us that we are explorers in an ever-expanding sea of the unknown. The universe's story is still being written, and every new discovery adds another chapter to this cosmic saga. So as we gaze into the night sky, let's embrace the wonder and uncertainty, because it is precisely this mystery that fuels our quest for understanding. The universe may be infinite, but so is our curiosity, and that might just be the greatest force shaping the future of all things. Thanks for joining this cosmic journey into the fate of the universe. If you enjoyed exploring these mind-blowing mysteries, don't forget to like this video, subscribe to Space Facts, and hit the bell icon so you never miss an adventure beyond the stars. Your support helps us bring more fascinating space stories right to you. Got questions or theories about the universe's future? Drop them in the comments. We love hearing from curious minds like you. Stay curious, keep looking up, and get ready for the next incredible adventure with Space Facts.